Thank you everyone for joining today's AIAA Los Angeles section, uh, the lunchtime fireside chat. Today we are honored and have a great pleasure to have Mr. Jim Duchovny from a very exciting company called Alef Aeronautics to answer questions. I'm pretty sure everyone was very excited about the new progress. They are making the first flying car. They got FAA approval. Um, so this event we have no like a regular presentation, but the CEO, Jim, he will show some video clips, and then he will open to a floor so people can ask questions. So we encourage you to click raise hand on Zoom so you can get a microphone access and to engage interactive conversation. If you, in case you really cannot speak out, you can type in Q&A or chat, but we encourage you to click get to click raise hand to get access. By the way, there's uh, somebody typed something here. Oh, Michael. So Michael, you have something to say?
No, I just wanted to set up my microphone.
Okay, all right. So I think Jim will say a few words about himself as well. So I don't want to kind of take off his time. But basically, Mr. Jim Duchovny is the president, CEO, and founder of this exciting company called Aleph Aeronautics. And I personally found it very exciting because for AIAA, as you know, it's American Institute of Aeronautics and Astronautics. And we are the Los Angeles section, and our name, we both have the aeronautics in it. So, and the eVTOL thing is very exciting progress in the aeronautics field. Um, so, um,
Yeah,
so
Rachel.
if you any, yes.
Uh,
Okay, so with this, I will turn it to Jim, so he will start the self-introduction and for his company and show the video and then start to answer questions. So, Mr. Duchovny, the mic is yours.
All right, so couple things to fix. First of all, we're not Aleph, we're Aleph. It's pronounced A with an
Oh,
opening.
very good. Thank you.
Second of all, we're not an eVTOL. Third of all, I'm only one of four co-founders. The other are Oleg Petrov, Konstantin Kisly, and Paul Markin. And unfortunately for you, I'm not the technical co-founder. I'm the CEO and the business co-founder. So
Okay, okay.
I know most of the questions are actually technical, which I can answer some of them. But it is my co-founders, Oleg, Konstantin, and Paul. That's where the technology expertise lies. I can briefly, very quickly introduce, just show you some videos in case you guys haven't seen those. So, first of all, first and foremost, it's a car, right? We're starting with a car. We're automotive company. We're having automotive market for automotive business model. It's meant to be a competitor or replace Tesla, Toyota, or something similar, not to replace Boeing, Airbus, or anything to do with Joby Archer and anything like that. In case you haven't seen the car in action, that's more of how it actually works. And again, to all the questions, that's not AI, that's actual video. Not sure why people thinking that it's AI. If it would be AI, it would actually fly much better. Then, right, so you might have seen this video, you might have seen this video operating in the semi-urban, if you want to call it, in a city, flying actually in a city. Here, again, that's not AI, it's just the car flying. So this kind of video, just for fun, we can fly over everything. We thought it would be fun to fly over Cybertruck. Um, that's another video of the car flying. And let me quickly explain how it actually works. So basically what it is we took engine and what was behind in the car out, and instead we put four motors inside four wheels. So it's a differential driving. Again, this is not a new concept, but the motors for driving are inside the wheels. Let's do this. Now, inside what is called DEP, distributed electric propulsion, you guys are probably familiar with this, obviously. It's just regular DEP, which is octuple distributed electric propulsion. On top, what we call this mesh. Mesh has multiple functionalities. One of them, it obviously allows the airflow, right, for the vertical takeoff. Also on top, it is that mesh provides a structure, as you've seen on the actual videos. And that mesh is also a safety mechanism against burst strikes, against anybody's trying to stick their fingers in. So basically, it actually protects the propulsion inside. On the side, there are elevons. The car actually does a transition again. I'll show you transition animation because the video of the actual transition hasn't been released yet. So since you guys are recording and asking, I cannot show you that. But that being said, I can actually share with you the animation and how it works. So for the transition, the point is that with today's propulsion, and this is just an animation. So with today's propulsion, whatever I just showed you does not have enough electric power to fly for like 2 hours, for example, right? The range would be very small, like EHang, for example, right? It has like a very small range, like eVTOLs. So in order to fly further, you obviously need to be more efficient. You need carrying surfaces. You need wings. The problem is if you have expandable wings, like somebody's trying to do, you cannot take off vertically anymore because you let me go back. So our constraints, because we're a car, we have to fit in the driving lane, we have to fit in the parking space, which means we have a extremely small area to work with. That's one of the constraints. Another constraint is a weight, right? There's a weight constraint. So all of this and we want a vertical takeoff and driving, right? To be both car and an aircraft. So to do that with these constraints, if you try to do expandable wings, you will not have enough power for vertical lift. That's why you see like Air Mobile and somebody else who actually take off from the airport. So we're the first ones who are able to drive like a regular car and be a regular car and have a vertical takeoff. I know Mueller tried it. He did, but not independent. I think he was tethered there. So basically, the idea is like you need wings which weigh 0 pounds. That contradicts the laws of physics. So where are you gonna have wings which weigh 0 pounds? That animation kind of explains it, and I have a bunch of videos, but I cannot show you that because it's still not publicly released. So what it does, it's like a 90-degree rotation. Basically, what it does, it reuses the body of the car and turns it into the biplane with a circular wing with a DEP inside, which makes it very efficient for flying. As you saw during the animation, the cabin is a two-way rotation cabin, which actually doesn't move. So now you actually have a pretty efficient, just to give you the numbers, in the rotorcraft mode without transition versus the biplane mode, what we call, it's a 7 times less energy consumption. Hence, it gives you much longer range here. That I think is a brief introduction, and I'll stop. So I'm sure you guys have more than enough questions on regulations, on business, on technology, on safety. Again, the big elephant in the room is safety. This is arguably safer than any traditional aircraft or any traditional helicopter. More than happy to answer the questions.
Okay, great. First, yeah, you mentioned something. If you want to show something that cannot be recorded, we can pause the recording if that's what you want. Then we can. All right, no worry.
I wonder is that.
Yeah, understand. We respect the your privacy and copyright patent. Okay, so folks, if any question, please. Um, okay, so somebody posed a question in Q&A. Is it what does the timeline look like for this technology?
It's a very open question. So, we started building the first one to be delivered, but that's going to be a controlled delivery, which means it's delivered to somebody who placed an order, but to somebody who we already know, which means they're not going to do anything crazy with it. They're not going to break their laws. They're going to be like using it pretty safe in a controlled environment. That being said, it takes months and months to maybe up to a year to actually build it. So this is kind of what you saw in those videos. We call it a pre-production model. Moreover, this is an ultralight model, and the next one's supposed to be a LSA model, obviously. As you know, ultralight has a lot of restrictions. As far as when I get interviews for like NBC, BBC, Fox, CNN, and so on, no, you're not gonna see it tomorrow or this year or next year flying huge amount of flying cars above your city. That's not gonna happen. It's gonna be very slow, controlled rollout.
Okay, thanks. So I don't know if it should answer the question for the that attendee. So I see another question. Okay, Mr. Good, I'll enable your microphone because I think this is a very good question. So let me enable your microphone. So 1 second. Mr. Here. Okay, Mr. Good, go ahead.
Oh, great. Thanks. Thank you, Jim, for launching this company and for your amazing foresight here. It looked like the vehicle takes off and travels basically straight ahead. By the way, I'm from UCLA. I'm a faculty in mechanical and aero. Can it turn in the air, or is it right now simply forward motion?
That would be really, really horrible vehicle if it could not turn. Yes, it does. It's just for recording video. Again, by the way, another important thing which I forgot to mention. We're a startup. We're a small startup. Most of the videos which you saw were recorded literally on iPhone, and those videos combined over all domains gathered over 2 billion people views. But we are a small startup, so yes, it would be nice to record a video where it actually turns and so on. As you see, we operate in a very constrained environment or an agricultural field, make sure it's very safe, there's like nobody around and so on. So it's not easy to actually record the video with turning. But yes, it's actually pretty good on the turning. You understand that distributed electric propulsion, right? Like because there are actually multiple microprocessors and multiple CPUs and GPUs control that. So with the differential thrust, it's actually pretty stable during the turns, and especially with also elevons supporting it, it's actually pretty stable during the turns, even on a relatively, well, we haven't flown at high speed, but even with a high wind, it's also very stable during the turns.
Great, thank you.
Sure.
Okay, Pradeep, go ahead.
Yes, can you hear me?
Yes.
Okay, thank you. I'm just curious about the implications of a flying car related to the uh, FAA rules because FAA is getting involved with the drones making deliveries and all that. I understand possibly this car is not going to fly at high enough altitudes like the drones, but will there be any implications associated with this? And also, I'm curious about how competitive will this vehicle be in comparison with the traditional land vehicles?
Okay. So let me answer the first question. The real answer is like a 5-hour answer. I'll try to get it into very quickly. So first of all, obviously it's under FAA, right? Everything. So by the way, the height, I'm sure as you're aware, it doesn't matter. Like the literal sentence which we heard from FAA, which is actually true. If you're 1 millimeter above the ground, you're already under FAA rules, which is actually true. So the height completely doesn't matter. There are different FAA classifications, remember, which I mentioned. So there is an ultralight, there is light sport aircraft, and there is obviously the full type certification, factory certification. The version which you saw in the video was an ultralight. Ultralight does not require FAA certification, does not even require the pilot license, but it does require full compliance, right? And there's obviously a lot of restrictions. That's what I was mentioning when I was set in a controlled environment, right? And under very strict rules. LSA removes some of those restrictions. But that being said, FAA, LSA, light sport aircraft, does require special airworthiness certification. We did receive before special airworthiness certification, the experimental version. And as you know, it has even more restrictions on that, right? So for LSA special airworthiness certification, that's not experimental, that's a different kind of special airworthiness certification there. So that's implication with FAA. Sorry, remove the question to the answer. It's actually much bigger. It has nothing to do with drones. We can actually fly it in altitude.
Where are we at on this? Are you ready to pull off?
Okay, thank you. And in terms of
wait, I haven't answered the question yet. So we can actually fly up to 5,000 feet and probably more. So it's not meant to hop over something. It can fly literally where
Have we done a final walk to check everything?
other aircrafts.
No,
I think you got some background coming, some audio from there.
there.
So that's basically related to your first question, even though there's much more to talk about it, and I'm happy to go deeper in this. Your second question is how competitive it will be to a traditional land vehicles. So there we're getting into why we need this type of car in the first place. So the traffic in cities, and especially from my understanding, you guys are from LA, doubles every 20 years. So if that trend continues, imagine Los Angeles with 2 times more cars, and there's literally no more room to actually make the lanes wider, at least inside the city, right? So you're getting into some pretty big problem, and think about why the cars were invented in the first place, to replace horses, right? To get faster from point A to point B than a horse. That's why cars were invented, right? That's not true anymore in cities. If you drive at 5 p.m. in Los Angeles, I can bet you that somebody on a horse can get there faster. So the value proposition of car is actually deteriorating. Again, the point which I'm not emphasizing because I think it's obvious, but people forgetting. This is a fully functioning car. That's the first video I showed you. It can drive the same way Tesla can. But in addition to that, it has the ability to take off and fly, right? So the idea is to give you a competitive product to existing Tesla, Rivian, Toyota, Ford, but which has additional functionality to bypass traffic, go over water obstacles, go over mountains, or go over something else, right? So it's just the same car, but it's actually more efficient. All right, we can go to the next question.
Thank you. I really appreciate that. However, another question that arises as a result of this car being operational is the traffic control. Suppose in a city like Los Angeles, you want thousands of these cars trying to jump over the traffic. How are we going to manage that?
Well, so first of all, you're talking about traffic, and you actually meant 2 different things when you said the word traffic. You meant traffic on the ground and you meant traffic in the air. Again, even 1 millimeter from the ground, FAA controls the air, including what you mentioned as a traffic. So first of all, you cannot take off from the freeway and you cannot land on the freeway. You can take off only from places where you're allowed to take off and land. That being said, it does not require to be an airport or a helipod, but you still cannot take off from a moving traffic. That's not allowed, right? In the air, the traffic is managed exactly the same way as it managed is today. Now, that being said, one of the implications of your questions were, what if there's like 1 million flying cars, right? Luckily enough, if you heard, so NASA and FAA had something which it was called highway. They still have it, something which was called highway in the sky. It's just now it has a bureaucratic name which I cannot remember. And by talking to people at NASA, it's just 10 minutes from my house. They also cannot remember the new bureaucratic name. I'll call it highway in the sky. So basically, it's a new system, which it's a traffic management system. Today, already the human flight controllers cannot handle all the traffic. You have AAM with flying taxis, which is eVTOLs, drones, flying cars, and a lot of other interesting things coming up. So basically, there's a new system which combines API calls and combines the digital traffic management, automated traffic management with human traffic controllers in a system. That gives it a much, much, much bigger scalability. And keep in mind, first of all, that system already exists, as being right now tested and rolled out. And also remember, I mentioned we're not going to roll it out immediately, like 1 million cars tomorrow above Los Angeles. It's going to be also very kind of like a staged slow rollout for that.
Okay, thank you. Appreciate the answers.
Okay, thank you. So next, Vinod.
Yeah, can you hear me?
Yes.
Oh, great. Thanks, Jim, for the exciting video. Although it was just a few minutes, it was really amazing to see literally a flying car. But my question was this idea that you have that you rotate the propellers, whereas the pilot remains in the gimbal, so to say, the gyroscopic gimbal. So how stable is that as given the motion sickness, etc., when you're transitioning, when you're landing, when you're turning? How stable is that? I understand gyroscopic, technology has gone way ahead, but I would like to know. It's a very interesting idea that you have this, and you make it into a biplane when you're going forward. So, can you please tell me about the stability, etc., of that gimbal?
Sure. So if you remember the video, and maybe I
can you show the video again? By the way, it was really nice to see it.
So basically, look at the rotation. Look at the human very closely. Human does not move and human stays in place. We call it a driver. You guys probably call it a pilot, right? So look very carefully right now at the pilot. Pilot does not move. What it looks like the whole body moves around the pilot. It's much more complex mechanically, but from the driver's standpoint of view, they actually don't move. The whole thing moves around them.
But this is
From
an
a mechanical
animation,
point
right?
of view, it's actually the opposite of what I said. But from the driver's
This is an
standpoint,
animation, right, Jim? Sorry. This is an animation. But you also showed the real one. Was it remote control or there was a pilot inside? The first
no,
video.
I haven't showed you the transition. Again, this is something we cannot release right now.
I see.
So the actual video of the transition we cannot expose right now. I have a bunch of them. We've been flying for like 3.5 years of transition. But it's very stable. It is stable, actually.
All right, thanks.
Sure.
Okay, Albert, do you have a question? Albert, Mr. Musa, you have the microphone.
Well, thank you. I had difficulty signing in, so I didn't watch the video at all. I'd like to see it again. I admire the fact that you are thinking completely out of the box, so to speak, but I want to see what you have. and
I'm
we
not sure
can talk.
which
Any
video you're
questions will
referring
come up.
to, because there were multiple videos here, but sure. Let me see.
Well, multiple videos is good. I mean, we want to appreciate all that stuff.
Sure, that's one of the videos. Again, you're welcome to ask questions as you look on the videos themselves.
Yeah, Albert, if you don't have a question, Mr. Molnar raised hand. He seems to have a question.
That's fine. Go ahead. I'll wait for later.
Okay. So, Mr. Molnar, go ahead.
No, I don't have any questions, thanks. I'm just listening, and I just put in some background about PK for his air traffic management group at NASA Ames that has been doing the development,
I know.
if it's of any benefit.
I talked to
Huh?
PK. It's been love-hate with NASA folks and specifically PK, but yes.
But as you stated, there are already rules in place, and we can operate within the existing rules.
Right. So right now, again, that's actually when I mentioned highway in the sky, I think PK is the one involved on the on working on that system. There's actually multiple groups inside NASA. But yes, we're designing to work at the existing rules without actually relying on a highway in the sky, which is again still being tested and being rolled out. So right now we're just another Cessna in the air when we take off.
Understood, yes. And I've been doing development for a long time. It's often a question people have about aerospace rules. But again, there's systems that have been in place since the 50s. And if you look up in the sky right now, even though we're in California and it's sunny, you probably won't see an airplane. So the least problem we have right now is over congestion in the sky.
Right. There are some, yeah, like the private airplanes are like very rare here in the Bay Area. I'm also in the Bay Area here. And again, we're not going to have like 1,000 or even 100 of those above Bay Area next year or even in 2 years. That's not how it works.
So if I do have one question for you, I guess it would be as far as an automobile, you have a four-wheel drive vehicle, and you're competing with other cars. What's your weight budget for your car as far as fitting all the regulatory requirements of a four-wheel car?
Oh, you mean so regulatory part on the driving part?
Correct.
Okay. By the way, you mentioned an interesting thing, and I'll just share the video again for those who missed it. That's an all-wheel drive. So this is the field where we test. And our cars get stuck in here, especially after the rain, and the Alef actually drives. Sometimes our car cannot even drive here, so it's actually pretty good at driving too. There's a different path for the different regulatory path for the driving. So first of all, we had two people who are not official advisors, but who gave us one of the best advisors, Mark Tapperning and Martin Eberhard, if you guys know who they are. Anybody knows on the call who they are?
Yeah, of course.
Good. Those are founders of Tesla. So the idea was to first make it a low-speed vehicle, LSV, which is, it's not technical limitation, it's just legal limitation, right? So technically it can drive like 100 miles an hour or even more. If we legally just limit it under 35, 25 miles per hour, depending on the state, we don't have to crash test and it's easy to comply with the rules. On the actually full compliance, it's also actually not certifications of compliance. On the full compliance with all the traffic authority compliance, this is much more complex. For that, again, we are a startup and we're doing things in stages. So this is the next stage, which involves funding. There has to be specific funding allocated to this compliance.
Have you considered, again, to my question though, it's not to engineer it, but have you considered what your weight allocation would be for that? And the answer might be no. I mean, what would it cost to drive as a car that would compete? So your suggestion that you're a low-speed vehicle, understood, that's a not a highway vehicle or that would be a low-speed vehicle, such as golf carts and similar, if that's correct. And then, so the question would be, what would your vehicle weigh to be able to drive on highways?
Got it. It already can. So the one I just showed you, can drive on, again, it's not, remember I said it's a non-technical, it's a legal limitation. Technically, this already can drive. It actually has a better suspension than most of the cars because our suspension doubles as a landing, right? So it has pretty good suspension, it has pretty good traction. The wheels are smaller, as you see, because of the weight. That compensated by other software/mechanical innovations, if you want, or other things which we did. So it is pretty okay. It can drive 100 miles an hour today on any highway and everything like that. It's just a legal limitation, not technical.
So it's not a licensed vehicle. It doesn't have a California license plate or a VIN. Is that correct?
So again, as an LSV, right? So on your thing, yes, we're actually working on both compliances.
Okay.
Yeah. But and we are driving off-road as of right now, as you can see, or on a private or closed off roads. But yes, technically, it's already there, and within the limit, within the weight limit.
Okay, thank you for your time.
Right. Again, I understand where your question is coming from because often in the industry, it is perceived that to make a good car, you have to make a crappy airplane, or to make a good airplane, you have to make a crappy car. That's not always the case. Like I mentioned, so
I'm not suggesting that at all. I appreciate your statement, but I hear that all the time, but I'm not suggesting that by any stretch. That's not a requirement. I was just curious about your weight budget again for being on the highway. And as you stated, that's something that's in the future for you. It sounds like you had suggestions to keep it simple at this stage.
It is simple. It can drive. Again, it's absolutely drivable on any kind of highway, on 101, on 280. It can absolutely drive today, technically, not legally.
Understood. That's the difference. Yeah.
Yeah.
And then I guess my question was, again, back to the first question, but it sounds like you haven't planned that out. What would be the weight budget to have one that is legally driving on the 101 with a license plate and a vehicle identification number?
I got it. So no, there's nothing technical additionally which needs to happen. It's just a human lawyer process which needs to happen. There's no additions which need to happen to the current environment to drive to the current vehicle to drive on 101 or 280.
Okay.
That being said, there's infinite amount of improvements on how well it can drive. The driving experience is not as good as in my Lexus. I can tell you that. It obviously drives much crappier on the road. That is true. That being said, it's okay. I have like a Mazda 2000, Mazda Protege from 2000. That drives about the same.
Okay, thanks for your answer.
Sure.
So folks online, so if you have any question, please click raise hand. So we'll give you the mic access. While we're waiting, I do have a question because I saw on your company website, you mentioned one of the good features of your flying car is the redundancy. Could you elaborate a little bit more? What does it mean and what is the advantage?
Sure. So if you fly today, I don't know, if you fly Boeing, Airbus, that usually has 2 engines. I don't know, like depending. Some helicopters have 1 engine. This one has 8 independent propeller, speed controller, motor, battery systems. What is important, they're independent of each other. So that gives you octuple redundancy. Obviously, it doesn't work like completely.
Is in automotive.
Sorry, there was a question? Yeah, so obviously it doesn't work like that because, for example, so as you saw on the video, there's 4 in the front and 4 in the back. So if 4 fail from one side, that's not going to be good enough. Good. All right. But basically distributed, like 6 of them can fail and it still can land safely. So that's redundancy there. There's also multi-system redundancy. In a biplane mode, it can actually glide. It can glide there. There is another thing which is not yet implemented but calculated in the software and everything like that. Because of such a lightweight, it allows ballistic parachutes. Again, they work at a certain heights only, but it does allow for ballistic parachute, full vehicle ballistic parachute, to again safely land. And there are other redundancy. There's, like we mentioned, there's like elevons, there are other systems which can step in. So basically, it just has more redundancy than your regular typical aircraft does.
Very good. Actually, there were a couple of people, they cannot make it today, but they are very interested. I was asked if it's possible a car, a model of your car can be brought down here in LA for display, not flying, just display in a kind of festival function.
So we were actually supposed to be there in March at I'm a big fan of Peter Diamandis, and he's doing like a very good conference. And he
Oh,
invited
okay.
us. Again, big fan of like his thinking and what he does. It just logistically didn't happen. So we were actually supposed to come to LA in March, but just logistically didn't happen. So nothing planned as of now.
Okay. I will ask you afterwards because there was a kind of festival in April, so I'll give you some more detail. But related to that question was not just display because the news Archer Aviation, they got this facility next to SpaceX for their test, like the test center and the hub. So do you have any plan for business in Los Angeles in the coming years?
Well, we don't have plans. That doesn't mean that nothing is going to happen, right? As of now, we don't have plans. We actually don't have that good connection with anything in the LA area for some reason. We have a lot of connections here in Bay Area, in some other states. Nothing, yeah, almost nothing in LA. But again, we're open to many interests. I know LA has an aerospace industry next to it, right? Like obviously there's many other interesting industries. So we're open to talking to anybody, but no, as of now, we don't have any connection to LA.
Yeah. I will chat with you afterwards. I can, we've been here and you're right. This is a traditional aerospace hub. So we have SpaceX, many Boeing, Lockheed, also Grumman, the traditional ones, and we have a new company too. And besides, actually, I don't know if you heard the news in Long Beach, our LA section, AIAA also cover Long Beach area. Recently, the Secretary of Department of War, he visited Rocket Lab in Long Beach, and they set up the Arsenal of Freedom. It's a very big kind of rocket stuff. And another thing is, the company using AI for drones, the Anduril that just spent $1 billion to expand their facility in Long Beach and Lakewood area. And there is another news. It's a vast space, but that's a space side. They also just bought 66,000 square feet in the Long Beach area. So there's a very booming for new aerospace activities. And of course, you have the Olympics, then you have the World Cup soccer and the Super Bowl. So it's very interesting. So, okay, Vinod, so go ahead. You can,
Can you
yes.
hear me? Yeah, I just unmuted. Okay. My question was, again, going back to a video, you showed one picture from underneath where you showed the 8 propellers. Can you stop it at that point and could we see what those 8 propellers, not the animation, I thought you showed it in your real life video. Can we see those 8 propellers, how they're located?
I don't know if there's any video which actually shows it from, well, first of all, there's no video which shows it underneath. I think in some videos where it actually flies, you can see obviously at some angle.
Okay, maybe it's your animation. Can I see that simply? I just want to see where your propellers are
Animation,
located.
I can let me
That's
see
okay.
if there's any videos.
No,
I
whatever you
think
just showed, you know.
videos are on purpose. I can show you the animation. The videos are on purpose done from the side,
I see.
so the thing is not exposed. This is animation. While
Yeah, from
animation is playing,
underneath,
let me
right?
see. Let me see if there are videos
And if you can
on.
stop it there, you know. Yeah, this.
This is obviously super simplification, right? Because this is animation.
Yeah, I guess so. So these are all staggered propellers. I'm not willing to say anything because of IP issues. Staggered in the sense in terms
No
of height.
propellers, no, there's no IP in propellers. Propellers are standard.
No, not the propellers. The arrangement of the propellers, are they at different heights when they're in the same row, one behind the other?
There is some IP in our okay, you are correct. There is some IP in the actual arrangement of propellers. Good insight. Good insight. Yes, that's actually true. There is some IP there. Yes.
But there are 8 propellers, you said, right? And
There
I
is
see
8,
that
yeah.
they're overlapping. So I was wondering whether they must be at different heights. Sometimes they don't, but
Maybe.
okay, that's all right. I know I'm skirting on IP issues now. But have you got a patent on this?
No, but good thinking. You're actually good thinking. So I like the way you think, and again, without saying anything out loud, yes, because we're working with a very limited space, we have to do something to kind of maximize the power. But yes, you're thinking in the right direction.
So do you have patents now, or have you applied for them? I'm sure you have.
Yeah, there are 2 patents granted.
Granted. Okay,
Each patent has multiple claims, obviously there.
I see.
So yeah, obviously. Yes.
Okay, all right, thanks.
Yeah, it looks like Mr. Breza make a comment there. He said his microphone doesn't work on his end. He said Angelinos are addicted to the car, so it's good place to be for that reason. Yeah, that's a good idea. Yeah, LA is a lot of cars too.
Right, and again, the idea is not, first of all, not to immediately replace the cars and everything. Idea is it's still drivable as the car, and you still would use it mostly as the car. It's just, I was about to say whenever you have traffic, but in LA it's probably 24/7. You would actually be less subject to the ground traffic, let's put it this way. But yes, the idea is over time, again, not tomorrow, not in 5 years, but long time ago, long time in the future to replace at least partially the traditional cars.
Yeah, I think about it because, I know the Silicon Valley there, but actually we also have this aerospace beach, Long Beach, Redondo Beach, Manhattan Beach, this area. So it's also very fast growing and booming. Peter, I see Peter has a question. Dr. Landecker, do you want to speak out?
Sure. Can you hear me?
Yes.
Good. Batteries are very heavy. What is the range as a function of payload weight?
Right. So for the Model A, and whatever you saw is not Model A, that's actually Model 0 ultralight. There's Model 0 ultralight, Model 0 LSA, then Model A ultralight, Model A LSA. It's full for us. So the full range on the 850-pound LSA Model A is maximum range in the biplane mode is 200 miles. Sorry. 110 miles in a flight and 200 driving. And that's an or, obviously, right? That's not an and, that's an or. That being said, in ultralight, obviously, because of the weight limit, it's fraction of that. And in a full version, which is 850-pound car, that's about, and again, this is a maximum, assuming 100% in the biplane mode. That's about 110-mile range on a flight, or about 200 miles range on the driving, or the combination of two.
So is it okay, Peter? Dr.
Yeah, that's
Landecker?
fine. Thank you.
All right, very good. Thank you, Dr. Landecker. There's a question in Q&A. He said he doesn't, or he or she said no microphone. He said, what CFD or wind tunnel tests have been done in developing this vehicle?
Right. So now we're getting to the development. So the whole reason we exist, right, and why you see eVTOL companies and flying car companies, which is not the same thing, is the advance of modern software, which allows you to design, doing the wind tunnel testing, doing the stress testing, doing all kinds of a flow analysis, all kind of CFD analysis. We actually have like most of the engineers and most of the time is actually spent in those tools to make sure there is every detail, especially in mechanical engineer, every single detail, every even small detail gets a huge amount of analysis for the where the weakest part is, the weight optimization, the flow optimization. Only after that it actually gets first 3D printed and then actually manufactured. So yes, to your question, these wind tunnel tests are done 24/7 on everything as we do it, and especially on transition, right? So it's all modeled. All those simulations are constantly running, and even small little change, obviously, as you know, can have a big impact. So this is actually the biggest, if you want to think about the time we actually spend on development and R&D, that's where the most of the time actually goes.
Is it good, Vinod? Any more?
No, he already answered my question earlier. This was somebody else, I think.
Okay, very good. So I saw John, Mr. Braza, you raised hand. Do you want to say something?
Can you hear me?
Yes.
Yeah, so I'm just curious, a couple questions. Have you been following the Icon aircraft? That is the amphibious vehicle that is a plane that lands, you take the wings off and you can trailer it. Because it's a similar model, but you just don't have the car. You just put the car on a trailer and you drive away with it. But
Did you say
it's called
X-Wing?
Icon Aircraft. It's an LSA as
Icon.
well. But the other comment really is that yeah, you should look it up. Icon Aircraft. It's quite it's a pusher prop, so it's not a vertical takeoff and landing. But their business model is an interesting one because you can land in water. But really, the question or comment I should say is that I believe that automobiles are dinosaurs. They're not going to be around in 10 to 15 years. So what's the whereas, flying cars and things like that will be around, I don't really see a business model for it in the long term, being able to just land and then drive away, a la do Android's Dream of Electric Street of the movie Blade Runner. But it's, why wouldn't you want to just land and get on an electric bicycle or an electric scooter or, other forms of transportation or a Waymo and be on your way where you don't have to worry about the engineering complications of having both, because that's always been the issue with the flying car. And it's been tried before, but not really ever taken off the ground. So I guess that's my comment. And just to round it out, secondly, that cars are dinosaurs. They're not going to be around in 15 years.
Well, I don't think it's going to be that quickly, but yes, cars would be partially replaced. And yeah, I know very well what Icon is. In fact, I talk to people from Icon. So coming back to your comment. First of all, you just answered your question. If you would take the actual points from, let's say, where you live and where you work, you actually map them, and you would try to do how would you commute, and you would put an eVTOL, you would put a bicycle, you would put a Waymo, you would put a combination. So first of all, combinations are not good. The bicycles and the e-bikes are really great, but good luck if you buy 5 watermelons from Safeway and you try to get it on a bicycle. Good luck if you're going to like an opera or somewhere like that and so on, right? So there, it actually doesn't replace the car. Having multiple modes of transportation is also not trivial thing, and what is not trivial is changing between them, right? In practice, if you think about eVTOLs, what is going to happen? They're going to go point to point, similar to a metro, but then you still need a second and actually third mode of transportation, right? Because it's a origin to the helipad, helipad to helipad, helipad to destination. Wait time for the transition is also there, right? So if you stop thinking about theoretical and start thinking about the practical, again, based on today's reality, that's based on getting on helicopter, getting like waiting for the bike to be free, waiting for the Waymo and so on, right? So this is in practice, we did this exercise many times in front of people, just using the Google Maps and the regular modes of transportation. The flying car always beat them. Sorry, not always. That's not true. That statement is not true. In more than 90%. In more than 90% of arbitrary points in the real life points, flying car is actually faster and more convenient because it's a personal ownership. And it actually it's more convenient and it is faster. That being said, that's an open question, and whatever happens in the future is always arguable and speculative. We don't know, as the COVID and other things showed, we have no idea what's going to be in the future. But this is based on a current environment, judging by what is happening today.
Okay, fantastic. I think
Thank you.
Albert has a
Appreciate that in response.
very good, very good. Albert has a question. Albert, do you want to speak out?
Yeah, actually, Jim, I got several questions. Crashworthiness, the kind of test we see that NISTA, one of them, subject to cars. What's your consideration on that point?
Sure. So this is, again, there's a theoretical and practical answer. Theoretical answer is it should pass. It actually should be better at crash worthiness than many cars. First of all, there's a bigger crumble zone in the front and in the back, larger than most of the sedans.
Bigger what zone? Sorry, what did you say? Bigger
Crumble
what?
zone. It's called crumble zone, right? So it's
Crumble zone. Okay. Mm-hmm.
distance between the front and the human, or the back and the human,
Mm-hmm.
right?
Got it.
So it also, again, on the side, it's questionable, but you also have a separation from the actual outside and the cabin. They're not next to each other, so they're separated by space. That's also there. You also, it's obviously a carbon, it's actually specially laid out carbon fiber and composites, so that's another separate thing there too. So there are some considerations. That being said, we obviously didn't crash test it, and that's exactly what I was saying. We're a startup. We just don't have enough cars to give one to actually crash test. That's the next step as we are going to the next round of financing. Part of that would be actually probably used for crash testing.
But you don't have let's say, a foot-pound value that it would withstand based on analysis.
Again, here we are similar to Tesla and everybody else. First, all of this analysis is done in software.
But do you have an actual number?
I don't have the number again.
No worries.
I'm not the
another point.
Co-founder.
Another point. It was
yes,
raised.
Obviously, it was analyzed in software. Yes.
A point was raised earlier. I'd like to expand on that a little bit. And the point was there have been other flying cars designs that came about 20 years ago or so. One particularly in New England, in the Boston area. And as I recall, they didn't make it. And a Chinese company
Terrafuji, and now it's called Aerofuji. Yes.
What's the name of the company, please?
Terrafuji. It used to be called Terrafuji. It was bought by Geely, and now it's called Aerofuji.
Okay. So what's the status of that now that the Chinese bought it? Can you tell us?
Sure, it looks exactly like Joby and Archer. It's not a flying car anymore. It's an eVTOL.
I see. So then what they did is kind of following what was said earlier by one of the speaker in your presentation, which is trying to have one system that does both flying and driving might ultimately make you fail in both, which is presumably what happened to Terrafugia or something. Do you want to expand on that a little bit? See, because this is a concern, and I'm sure you have, but I want you to share your thoughts with us.
So first of all, Terrafugia was actually a good car and a good airplane. They just needed airport to take off. So the business model was not there. It was a good car. It transitioned, remember, so like it expanded the wings, right? And then it transitioned
Right.
into the airplane.
Yeah.
It was okay car. It was that. Like, I don't think they sacrificed anything there. We, on the other hand, have like much more constraints than Terrafugia is. And as I mentioned, it's a separate motors for driving and separate motors for flying. They do share the electrical and kind of CPUs, GPUs, like sensors and so on. Otherwise, the systems are separated in our case.
But in your statement, when you said you have to go to a heliport, well, some port, to take off from and to land to, that's going to limit significantly what you can do with it.
Good. Now you're getting into the point what flying cars versus eVTOLs. That's very good. So flying car does not have to go to a helipad. eVTOL does.
But your car, you said earlier that you cannot take off from, you're driving, you're stuck in the highway, then you take off and fly.
You cannot take off from the highway. That doesn't mean you cannot take off from any surface. You can literally take off from any surface except water at this point. Again, going back to Icon, right? But you don't have to go to a specific helipad. You can actually take off from any surface. But you cannot take off from the highway for the safety reason.
And you cannot land on the highway either?
Of course. Like, that's even worse.
Yeah, of course. Okay. All right. Understood. Wish you best of luck. It's a tough one. Whether it's going to take 10 or 15 years, I don't know, but it's a very tough.
I don't think it's 10 and 50 years. Like I said, we plan to deliver first one within a year, but yes, thank you.
Best of luck to you. Thanks.
We are reaching 1 p.m. right now. So it is the original ending time for the chat here. Unless somebody has a question quickly, I don't see any. So personally, I have a lot of questions, but this is 1 hour lunchtime fireside chat. I know, so maybe in the future we have another great opportunity with Jim, so we can chat more. So if there's no more questions, so let's thank Jim for this wonderful fireside chat. It is wonderful. So we'll continue the communication and see if anything, AIAA can work with you. Something like that.
Okay, let me just finish with this.
Yeah.
So if judging by the questions and judging by, like, we know, like, if you look at the YouTube videos and everything, there's a lot of misconceptions and a lot of things like, what if there's like a bad drivers in the air, the questions about the safety, the questions about legality, and so on. The best thing to do is actually, again, something like this, where you do ask tough questions, and I love that. The tougher the questions means the more you actually trying to understand this. So I really appreciate this. And just going through the misconceptions, right? Because I think people have some kind of a model in their mind, which is not what reality is, right? How the legally it works, how safe it is, and how it fits into existing model, what is going to happen in the future. So more than happy to answer those questions. I hope I did answer some of them. If you guys have more questions, you can find me on LinkedIn. And you're welcome to also publicly comment. Like I said, open to any questions. The tougher question they are, it's better because it helps to remove some of the misconceptions.
Yes, agree. For example, I have a simple question like, how people get the license in the future for driving this flying car. There also the manufacturing issue, and then can you assemble it? Those kind of things at home, like you assemble a drone or something like that. There's a lot of very interesting potentials. But yeah, if anybody have any question, you can also forward to me. I can also try to get forward to Jim. So you can also find him on LinkedIn. That's a great thing. So AIAA here, we are trying to facilitate, the understanding, for the future aeronautics technology, and try to help for kind of society to understand, and for business to see if anything that the society, the community can help, those kind of things. So Jim, do you have any more thing you want to conclude?
I think that was it.
Okay, so we'll encourage people to come up with more good question, tough question, and we'll let you know.
Right. Thank you, guys.
Okay, thank you so much, James. Thank you, appreciate it. Thank you very much. For everybody, this Saturday we are going to have a Space Shuttle Challenger event, STS-51L. Welcome to join us. The 1 a.m. presentation and the 1 o'clock discussion, they are online, but the video session at 11:30 and the 2 p.m. They are copyrighted, so it's only in person in the Longdale Library. And afterwards, next Saturday, February 7th, we're going to have a Career and Workforce Conference in Lomita Library. So thank you so much. So let's follow up with this wonderful aeronautics topics. And so thank you very much. Have a wonderful day, wonderful week. See you next time.